All right, ladies and gentlemen. Hopefully you're where you want to be seated, ladies and gentlemen, because I don't have a seating chart. So tomorrow, if Faith gets here earlier, she's going to be sitting in Victoria's seat. I got to be like, or in Zoe's, one or the other. You think it's Zoe's? You think Zoe's the problem? Let's not go there. Let's not go there. I think you're the problem, not Zoe. All right. Again, ladies and gentlemen, we are in the second half of the conceptual chemistry course that we started for you guys. Some of you in the very first try, for some of you in the second try, but this is Unit 5 starting today, ladies and gentlemen. Okay? So, a couple of things. Number one, come up to the front desk if you do not have your periodic table from the earlier try, whether it was last try or the first try. You may want to come up and grab one, ladies and gentlemen, and you may want to grab one of these because you can use them on any test or any quiz that you are going to take in here. And again, I'm sorry, for those of you who had me last try, you're probably like, why is he saying this? Well, some of you didn't have me last try, so some of you it's been a while. So I don't necessarily know for sure that you kept everything that you needed. So they're up here if you want to come up and grab one, ladies and gentlemen. If you have yours, please take it out so we can make sure that we have everything on it that we need to, ladies and gentlemen. Okay? Everything on it that we need to.
Yeah, I
Good morning, Christian.
Oh my
Take
God.
a seat in the first 3 rows.
Hey.
I walk in, you say nothing. He walks in, oh my God! What the heck?
Apparently they like him better than
Apparently. It's okay, Faith. Nobody listens to you.
I listen to you, Faith. It's okay.
What's that?
Where's my apple?
If you were expecting something different from me this try than you got the last try, whether it was last try or the first try, ladies and gentlemen, I am the most consistent person you will ever meet. So, all right. All right. Hey, what?
So my birthday is coming up.
So you're going to bring treats in that day. Is that what you're saying?
Can I get like a bouquet of like apples?
Can you get a bouquet of apples? If you go to a store and buy them, you can. Yeah, I don't see why not. I don't see why not.
I thought we had an agreement that I was going to get apples.
We were, and then you ditched me on that day.
I did.
So
Yeah, you did.
that agreement goes right out the window.
You always made agreements about apples, ice cream.
She was always really kind of needy, wasn't she, Zoe? I agree. All right.
No, we're messing with you.
No, I'm being honest with her, to be honest with you. Okay. All right.
You're gonna cry now, Mr. Brandon.
It's okay. I don't mind. You think it'd be the first time I had a student cry in my class? Come on.
Do you still have that dead body from first try?
You cannot prove anything. So, ixnay on the talk scale of body scale.
All last time he said, if it kills you, I had to make you do
I got it.
Christopher.
You like everybody in this class but me, huh? Okay, I got it.
Can you mark me tardy?
I will mark you tardy. Why wouldn't I mark you
Some
tardy?
people, some of these teachers, when I'm late, they mark me absent.
What?
Well, if you wouldn't be late, you wouldn't get marked anything. Right? All right.
Mr. Brandon, I said welcome the very first day I met you.
Well, I'm glad you're all back. I really am. Okay?
Get to deal with Faith.
I can handle Faith. Faith is not that hard to deal with because what I basically do is ignore her 90% of the time. Okay, what happened there?
But now I'm questioning it. I like messing with you.
I don't blame you. I would question it too.
I like if people mess with me, I mess with them.
All right, he meant I was not here.
Poor Faith.
Holy cow.
We're still cool, Faith. We're at Drummond.
Since
Let me color coding.
we go through
this one, of course. And I got
All right.
That were
after this, I got
3, 6, 7, 8, 9, 10, 11,
Happy
12,
FL.
13, 14, 15, 16, 17.
IPFL.
whatever.
17, perfect.
You have
Perfect.
what?
Perfect.
PFL. I have PFL.
All right, ladies and gentlemen. So,
four periods.
couple of things. Let's start with our periodic tables. If you don't have yours from last try or from the first try, come up and get one.
I'm highlighting
If you're going to be taking some notes on there, I do have red and blue pens up here. I have some highlighters for things that we're going to need. So you could come up and you could grab those if you wish, ladies and gentlemen.
I know I'm highlighting right now.
So
Boy, I just
here's the important things that we need to put on there, and I will add a little bit more to this in a minute, ladies and gentlemen. So let's start up at the top here, ladies and gentlemen. So I'm going to zoom in a little bit.
That again.
Okay, Zoe, easy. My turn for a little while. All right, so up in the upper left-hand corner of the periodic table, ladies and gentlemen, VE stands for valency electrons, and I'm making a note of that. Everything in group 1 has one valency electron, so that means hydrogen, lithium, sodium, all the way down, ladies and gentlemen. So at the top of the group, I have 1 VE. At the top of group 2, I have 2 VE. But I also have a note up here. Metals lose electrons, get a positive charge, and become a cation. Exception to the rule, hydrogen can act as a metal or a non-metal. So again, these are just some notes that we need to put on there, ladies and gentlemen. Some notes so that we have them, so that they're there for us when we need them. And again, if you had your periodic table in the first try and you don't have it anymore, or even in the last try and don't have it anymore, this is what you're going to need.
Mr. Brown,
Yes, Ethan.
what's that cat ion again?
Cation is a positive charged ion. So if anything has a positive charge, it is called a cation.
Mrs. Dart, I thought you only teach math.
No, we're putting her in a good subject now. Leave her be. You know what it is? Everybody just wants to be in my class.
I'm gonna go that far.
Ethan, can I remind you that I control your grade in this class?
Oh, Ethan, you screwed.
Already testing those limits, huh, Ethan?
Mr. Brand, I'm like not your favorite student, right?
You are not my favorite student. I don't have favorites, Ethan. But you guys, I'm getting the feeling you're going to be my favorite first period class this trimester.
Only first hour.
We were your favorite last hour.
No, you were not my favorite first period class the last
No, you were
trimester.
our favorite fifth hour.
Well, that's different this
That's
trimester,
what
Zoe.
I was saying.
He had
Jasmine's
favorites.
still over there going, you aren't any funnier than you were the first try. It's okay, Jasmine. You're all right.
We like to mess with you.
Jasmine, are you going to survive as the lone wolf of your pack left in the class?
I
What?
was in her.
Well, no, there was a group of 3 that you hung around with that you were part of, and
They're not here no more.
I know you're the last remaining soul. Kayana, she stuck with me for 2 hours right in a row, like poor Kevin is.
You want to know what, Mr. Man? You don't have to deal with those 3 that sit in the back.
Well, that's because I'm not letting anybody sit in the back, Zoe.
No, those 3 that sit together.
Oh, don't worry. Things will be back where they're supposed to be eventually, ladies and gentlemen. Poor Alex, yeah, he got separated from his group too. Don't you hate it when they change schedules?
Yes, I really do.
Ethan and Christopher, though, they stayed together.
You said what?
They're bonded at the hip, ladies and gentlemen. Okay. All right. So, over in the other corner, ladies and gentlemen.
I wasn't.
Now, sorry. Well, write and quit talking.
I'm sorry. You put all the good kids in here.
What?
Put all the good kids up
I didn't schedule any of you in here. No, thank the guidance department. They're the ones who do the scheduling.
Okay, you can move it over now, Mr. Brand.
Okay. By the way, ladies and gentlemen, all the grading, everything that we did in the first try, same in the second try. You're going to have 4 units just like you did in the first trimester. We've got 4 units in this trimester, ladies and gentlemen. You're going to have labs. You're going to have quizzes. You're going to have homework. You're going to have tests. Which of those doesn't count toward your grade?
The homework.
The homework still doesn't. Yes, Ethan.
We should, or not we should, but should we put the charges on our periodic table?
Yes, you should as well. Now, the reason you didn't see the other ones is because they're down at the bottom, and I will get to those in a minute. But yes, 3 valency electrons, 4 valency electrons, 5, 6, 7, and 8 valency electrons, a charge of -4, a charge of -3, a charge of -2. Make sure you get these in the right spots, ladies and gentlemen. Over carbon, over nitrogen, over oxygen, because again, that tells us the charge of that element if it is in an ionic compound. Okay? And then our notes, nonmetals, do the opposite of metals. They gain electrons instead of losing them. They have a negative charge, and the term for that is an anion, ladies and gentlemen. Yes, Christopher.
Where do you get your shirts?
Where do I get my what? At a store. I don't know. I've gathered them over the years. Wow.
I want a copy paper.
Okay, they are, but here's the problem. Nike doesn't make very many good polos anymore. They're not doing well in my
That would hurt
expectations.
to look like.
Yes, Cam.
For helium,
Yes.
what is the valence electron?
Okay. No. That's why I have this asterisk in by helium. And the asterisk means that for helium, there are only 2 valence electrons. And the reason for that is the first energy level, and the maximum number of electrons in that first energy level is 2. That means helium is still full and stable, but it is the one element that is stable without 8 valence electrons. It is stable with only 2 valence electrons. Everything else in the family, though, the reason I have the 8 valence above, neon, argon, krypton, all the way down, they all have 8 valence electrons. They are all stable. By the way, ladies and gentlemen, this is your section of the board up here. I'll put reminders on here about when quizzes, when tests are. I will post them on the agenda daily too. But here's where they will be at when you come in. When we give you assignments, labs or homework, they will go up here, ladies and gentlemen, just to remind you of what's due and when it's due and things of that nature. Does anyone need the top of this more? We're good? Okay. By the way, this volt zigzag line here, that's the line that separates the nonmetals in the upper right-hand corner here from the metals that are on the other side of that line, ladies and gentlemen. Okay? Oops. So, down at the bottom here, ladies and gentlemen, as Ethan was saying, here are the positive charges. And the reason we put them down at the bottom is because when we get into here, ladies and gentlemen, these are negative charges up at the top above the bold zigzag line. Below it, these are positive charges. Okay? So under francium, we have a +1. Under radium, we have a +2. Under nihilium, we have a +3. And under whatever the heck FL is, we got a +4.
You getting your tongue twisted today?
No, we don't use those ones very much, so I don't remember what their names
I
are.
said you're getting your tongue twisted.
So, okay, we could say that as well. Couple of special elements. By silver, put a +1. It is always a +1. And it's in a lot of compounds. That's why we have you write the charge down. By zinc, it is always a +2. Zn, number 30, is a +2. Silver, Ag, number 47, is a +1. And then tin and lead here, even though they are in the column where they should be a +4,
It can be
a
also
lot of times they act like a +2. Okay? A lot of times they act like a +2.
What's the one that can be a negative and a positive?
That would be hydrogen up here. Hydrogen could be a +1 or a -1. Very good. Okay?
So tin can be a +4 or a +2?
Correct. Tin can be a +4 or a +2. And there are a lot of elements. They're mainly in this area, though, where they can have multiple charges. So, for example, bless you, iron can be a +2 or a +3. Cobalt can be a +1 or a +2. Copper can be a +1 or a +2. So those that are in there, we don't know their charges other than the ones that I gave you, which were silver and zinc. Okay? Questions? Down at the very bottom here, there is something else that we need to write, ladies and gentlemen, and that is what is called diatomic molecules. Now, what is a diatomic molecule? A diatomic molecule is when you have two of the exact same kind of atoms bonded together to each other. And the reason they do that is these elements are so reactive that even if there's nothing else around for them to react with, they will react with themselves, they will share electrons, and they will become stable. So if we were to talk about hydrogen gas, the way we would write it would be H2. If we were to talk about nitrogen gas, we would write it N2, O2 for oxygen, F2 for fluorine, Cl2, Br2, and I2. Now on this periodic table up here, ladies and gentlemen, those are all marked out in green. The dark green color here. So again, just something to remind you of, okay, is that those 7 will react with themselves even if there's nothing else around for them to react with to become stable. Okay? In a compound, you don't have to have 2 hydrogens. In a compound, you don't have to have 2 oxygens. You can have 1 oxygen. Why? Because in a compound, it's becoming stable in another way. So in compounds, you don't have to write these with a 2 after them, only when they are alone. So if we were to write iron as an element, we would write Fe. That's it. If we were to write silver, we would write Ag. If we were to write potassium, we would write K. But if we were to do oxygen, we would do it as O2. It's never alone. It's never just O. Okay? It's never just O. It's either O2 or it is what it is when it is with something. Okay? When it is with something. Questions? All right. A reminder for you. Anyone need more time with this, by the way?
No.
Good.
Oh, that reminder of the
That reminder, chemistry. The science.
The atom.
The study of matter.
Hold on, Zoe. I get to do this. My definition. The science of the study of matter. Its properties, structure, composition.
Isn't there atom up in there?
Hold on. What?
Isn't there atom somewhere
Nope.
in there?
No, not at all. The science of the study of matter, its properties, structures, composition, and the changes it undergoes.
So like this for every test.
That is our definition, ladies and gentlemen.
This is for every test.
Good. And there is 6 points here. That is what I graded on when I look for your definition. If you are going to get 6 points, you have to have the science of the study of matter, property, structure, composition. I don't care what order you put those in. Okay? If you accidentally screw up that order, it doesn't matter. And the changes it undergoes. That's how I get 6 points out of this definition, ladies and gentlemen. That's how I get 6 points out of this definition. Okay? Questions?
You want to make us hungry with this unit.
Oh, you haven't even seen it yet, Zoe. Relax. Relax. All right. Anybody need more time with the definition? Okay. If you did take pen or red or blue pen, or if you want to grab a highlighter, ladies and gentlemen, there are a couple of other things we need to do on the back of our periodic table that we're going to do right away, ladies and gentlemen. So on the back of your periodic table, we talked about these things on the back. These are our polyatomic ions that go into compounds occasionally. So we got into naming things with this, ladies and gentlemen. We really didn't get into the things over here, so that's okay. We're not going to worry about ites and hypos and pers, okay? But I did highlight this one polyatomic up at the top, ammonium. If you want, there are highlighters up here. You can come up and grab one. The reason I highlighted it is because it is one of the positive polyatomics. Matter of fact, it's the only positive polyatomic on this list. So it will sometimes begin a compound for you, ladies and gentlemen, in place of a metal. Okay? We're getting to that, Zoe. You got to let me get to this stuff. You just had this. Remember, there are others who haven't. We'll get there. Okay? So I highlighted ammonium because it is a positive one. Okay? I highlighted ammonium because it is a positive one. And if you have a compound that has 3 elements in it, but does not start with a metal, it's going to have ammonium in it. Okay? 3 or more. If it doesn't start with the metal, if it doesn't start with copper, if it doesn't start with iron, if it doesn't start with sodium or potassium or any of those on the periodic table, nitrogen is a non-metal. Okay? But it is part of this ammonium group. I also highlighted these 4 down here, ladies and gentlemen. Now, we won't use these very often, but I highlighted cyanide, ferric cyanide, ferrocyanide, and hydroxide. Any idea why?
Because they're important.
Not really. 3 out of the 4 we'll probably never use. But I highlighted them for a different reason. Anybody know why? Well, what's different about those 3 from all of the other ones that we have not highlighted?
They have IDE.
Thank you. They have IDE at the ending. Now, when we named compounds, and for some of you it was a while ago that we named compounds, our binary compounds ended in IDE. Sodium chloride, magnesium fluoride, aluminum oxide, copper sulfide. They all end in IDE. Most of the polyatomics on here end in ATE. However, there are 4 of them that do end in IDE, even though they are polyatomics. Now, of the 4, the only one that I have used ever in class is hydroxide. Okay? I've never given anyone with a compound with cyanide in it, or ferric cyanide, or ferrocyanide, but they do exist. Okay? But hydroxide is one where it does end in IDE, And it's amazing how people will sometimes put down a formula for hydroxide as just an O or just an H, and that doesn't work out. Okay? So it is actually an OH. Now, I do want you to cross one off too, down there near the bottom. After oxalate and before phosphate, there was one that was permanganate. Please just cross that one off your list. We won't ever be using it. The nice part about the print center downtown is they run me 1,000 copies of things, but now I've got 1,000 sheets that have the wrong polyatomic on it, so we have to cross it off. Okay? All right. Questions, ladies and gentlemen? All right. Anyone need anything else before we get going? All right. Take out your computers then, ladies and gentlemen. Open them up. If you need a charging cord, which I can't imagine any of you would, but maybe, just maybe you might. I have a couple of blocks up here. You can come up, you can grab one with a cord, ladies and gentlemen. I set up a new Google Classroom site for us, ladies and gentlemen. This is yours. There should be an invite if you go into Google Classroom for the class. I sent one out to all of you. Some of you have already accepted it. Some of you haven't. If you didn't get the invite and you go to Google Classroom and it doesn't say Conceptual Chemistry Units 5 through 8, please let me know and I will send you the invite, or I will give you the code that you need to get into the classroom. Okay? So we will get that for you. Something new I am trying this trimester for you guys, ladies and gentlemen. I did the daily agenda before. Yes, sir. Sure. Anybody else? 2? We're good? All right. Christopher, what's your percentage on your computer? Dead. Totally dead. 0. All right. Who else has got a block? What? Dead? Because I only have one left.
I have my charger.
Okay. You got enough, Christian?
Yeah.
Okay. Thank you. I'm sorry that with 2 freshman classes next door, they're all gone. Okay. On the daily agenda, ladies and gentlemen, again, if you open this up, this is the calendar for the day. This is a link to that daily agenda that I showed you at the start of the hour. We will go back to it in a minute, but I'm also going to try to do this for you this trimester, ladies and gentlemen. So while I've been up here and while we've been talking and while we've been going through things, ladies and gentlemen, I've been taping everything that goes on the screen and everything that you say, and you're going to be on YouTube someday, ladies and gentlemen. Okay? So I'm going to record the class video of our lesson so that if you ever miss a day and you want to go back, you can catch the lesson on YouTube. Okay? You won't see me. You won't see anybody in the class. All it shows you is the board, and you'll hear what we were talking about. So if you miss a day, that's the way you can go back and you can find it. Or if you didn't understand something, you can go back to it. So by the end of the day today, I'll have the video link to that, ladies and gentlemen. It'll take you to YouTube where all the videos are at for my class. Okay? So just an extra thing, if you ever miss something or spring break is coming up, some of you may be taking spring break early or something like that. If you miss a day of class, here's where you can find out what we did and actually watch the video for that day. So, questions? Excellent, excellent. All right. So, ladies and gentlemen, again, this was at the start, our agenda, and that is what is linked in there as well. Okay? So what did we do in the last part of this class that you guys enjoyed that you would like us to do more of in this try?
I liked one of the lab last try.
So you like labs?
Yeah, one of them I really liked was the where you made the suckers.
Okay, but now understand, we're not doing that same lab again. We've already done it. Okay, so you want edible labs. Okay, got it. What? That would be edible labs, what she just asked for. Okay, good, got it. What else? What? More Oreos. Okay, edible labs. I understand. You want to eat things. Got it.
The penny lab was full. Don't want to use.
Any lab.
I think we need put some liquid in there.
Oh, okay. All right. So demonstrations like that where we blow things up or disintegrate them or things like that. What?
We didn't get to blow things up.
You got to blow up a balloon. I handed you a balloon in class one day. You chose not to blow it up, so knock it off. What else?
Yeah. Working collaboratively.
You must have not been here that day. Or he whined more than you did, which was probably impossible to believe that day. But anyway. What?
Working collaboratively.
Okay, working collaboratively with one another. All right, good. Anything else?
That's a big one.
Again, I got the edible part. I got the fact that you guys like to eat. You know what? Breakfast is served before this. Get to school early. They can give you breakfast. No eating in my class.
Poor Faith can't do that.
The Quizlets for reviewing. Okay.
Poor
Okay.
Faith can't do that. Traffic's horrible for Faith.
Well, Faith will learn to leave earlier. It won't kill her.
I can't wake up.
Yes, you did. You are proving that wrong right now.
I can't wake up on time.
That may be the case. All right. Today we're going to start talking about energy, ladies and gentlemen. Okay? We're going to start talking about energy. Now, here is the other thing, and I will be very honest with you. This class is not a hard class to pass if you do the things that are asked of you. If you're not going to do labs, you better do really well on tests and quizzes. Because if you're not going to do labs, you're losing 20% of your grade. Which means then if you average an 80 on your tests and quizzes, you are at about a 60% for the class, which is close to failing. Okay? So if you do your labs, that gives you more cushion. So there are a couple of ways of getting through this class. One, do well on quizzes and tests. That would be the best way. But the second way is do your labs. Get them in on time, get full credit on them, earn your maximum points on those, and get those points in the bank. Because then it isn't as important that you do well on every test. Okay? Yes, you're going to have to do well on some tests, but you don't have to pass every test in this class to pass the class. But you do if you don't do the other work. If you don't do labs, you're losing 20% of your grade. If you don't do a test, that's a 0 on a test. That kills your grade. So again, take care of those things. And if you miss a test, you can make it up during class time. I'll put you next door to do the test, to do the quiz. Okay? But you got to get it done. All right. In your Google Classroom, ladies and gentlemen, there is a new assignment for you. So under classwork, go and find the Unit 1 or Unit 5 EISN and open it up, ladies and gentlemen. That is your new notes. Now, again, here are the master notes for the class. I think you guys only have 3 things in there right now, correct? Under Unit 5, there are 3 things. There's the EISN, the master notes, and then up at the top is the worksheet answer keys. So there you go.
It's in the daily agenda.
Okay, and then the daily agenda above that. Yes. So I have some things in here that you're not seeing because I haven't posted them yet. So if you open up the EISN, ladies and gentlemen, here's what it looks like. So right now, I want you to tell me what the source of energy for in each of the following. What is the source of energy for a car, ladies and gentlemen? What makes a car go?
Gasoline.
Okay, a standard car, not an electric one. Let's go with that. Zoe, what makes it go? Gasoline. Gasoline is the energy source for a car. Now, Ethan brings up a good point. Nowadays, there are new cars that are electric. What would be their energy source? Nope.
Electric.
Electricity.
The what in them?
Oh, battery.
The battery. The battery. Yes, you have to charge it, and I understand all those things. But the energy source in there is the battery in the car, just like the battery in your cell phone. Okay? That is the energy source for that thing. What is the energy source if you have a pet? The food that they eat. The food that they eat. Okay? So we all need an energy source. For a car, it's gasoline. For a pet, it's food. What is it for a tree?
Water.
Nope.
Sun.
Sunlight. Sunlight. Now, again, trees do need water, Victoria. Absolutely. No question there. Okay? Absolutely no question. But water is not an energy source.
Yeah.
When you drink water, it has no what in it? No calories. And calories is a way of measuring the energy in food. So if you eat something that has no calories, you're not getting any energy from that. None. Okay? How about a cell phone? Battery? Okay? Now, some people would say what though? Which is what then? Electricity to charge the battery. Okay? Either way. Okay? Laptop computer.
Battery.
Battery again. And again, ladies and gentlemen, if you would like to make a lot of money in your life and become very rich, invent a small, lightweight battery that can hold the charge long enough to run your cell phone for a full week without having to charge it. You would make a lot of money, ladies and gentlemen. A lot of money. And the problem is there are batteries out there that can do that for a week, but they're huge, and they make your cell phone too large, and they make it so that you can't put it in your pocket. But yes, there are batteries out. If we have a battery that can run a car, we have a battery that can run a cell phone for a very long period of time. The problem is we don't have a small battery for your cell phone. What about a desktop computer? What?
Power cord.
Which, okay, but what is, power cord means nothing. There, power cord not hooked up to anything doesn't do anything. So, electricity. Electricity. All right, what is your energy source, ladies and gentlemen?
Calories.
The food that we eat, ladies and gentlemen. Yes, calories does measure how much energy there is in that food. Okay? But the food that you and I eat, that is our energy source, ladies and gentlemen. Okay? So, in chemistry, we are going to look at this point in time, energy in things. Okay? That is what we are looking at. Now, there are three definitions here. The ability to do work when you apply a force and an object moves some distance and a push or a pull. Now, if you take and click on each of these boxes, they will complete this rectangle for you, ladies and gentlemen, when we put the right box in the right spot. So, energy, force, and work. One of their definitions is the ability to do work, which, by the way, is probably not what? Work. So you got a 50-50 chance there. You're either going to give me the right or the wrong answer. When you apply a force and an object moves some distance and a push or a pull. So which one do you know that we could put right away? Ethan.
Force is a pusher.
Okay, a force is a push or a pull. All right, so what is energy or work then? The ability to do work is energy, which means work must be when you apply a force and an object moves some distance. And a force is a push or a pull. Okay? A force is simply a push or a pull. Now, the one that I would like to talk about for just a second is this one right here, work. That is a scientific definition of work. That is different from you saying, oh, I got to go to work today. You may go to work and your job may be to sit there and run a cash register and you don't really move anything during the day. And yes, you are working, but that is not the same as the scientific definition of work. Okay? The scientific definition of work is when you apply a force and an object moves some distance. So also, ladies and gentlemen, if you go up to the weight room after school, put a bunch of weights on a bar, go to lift it, and you don't move it, guess what? You have not done work. Because it has not moved some distance. Okay? Am I applying a force?
Yes.
I'm pushing on the door. Am I doing work? No, I am not. Am I using energy? Yes. And that's why energy is the ability to do work. You can burn energy without actually doing work. Okay? I used to hate, as a kid, going to the grocery store with my mom. Because it never failed that as you were leaving the grocery store, and she always said, oh, we'll just carry the bags. It's okay. We'll carry the bags to the cart. We're not taking the cart. So you had your hands loaded down with bags, and you'd be walking to the car. And what always happened?
A break.
No. She ran into somebody she knew.
I hate
So now you're holding these bags, standing there while they're talking about something you could care less about. Can I get you? I'll just be a minute. Just wait. No, let me go. No, I'll just be a minute. Just wait. 10 minutes later. Can I go to the car? No! And now I'm starting to sweat, carrying these bags. You can't put them down because she's like, don't put them down. You know, you're going to break the bag. Are you doing work?
Yes.
No, you're not moving. Those bags are just standing there. Are you using energy?
Oh.
Yes. Okay? So again,
Yeah.
you go to push something, it doesn't move. Yes, you have used energy. No, you have not done work in the science world. Okay? You have not done work in the science world. Okay?
That's why I don't go to the
Hopefully
store.
your parents don't make you do that to you.
That's why I don't go to the store with my
All right. So,
I don't know.
in terms of energy, these are different kinds of energy, different forms of energy. Thermal, chemical, nuclear, electrical, electromagnetic, and mechanical. Okay? So we've got some things up here that we can match them with. Okay?
Mm-hmm.
So thermal energy is what really? Heat. Okay? Heat. So sunlight, fire, a match, all give off thermal energy, ladies and gentlemen. Thermal energy is heat. Okay? Heat. By the way, thermal energy is given off anytime an object does what? What? Gave off. So anytime it gives off heat, it's giving off heat. Okay, no. Anytime there is friction between two objects. Friction, okay, between two objects always generates heat. Always. Always. Thermal energy. Okay? Matter of fact, this is one of the biggest wastes of energy in a car. Is friction between the moving parts. Because it gives off heat. Heat that we don't necessarily need. Chemical energy, ladies and gentlemen. Match, battery, food. Okay? We get our energy from chemical energy stored in the bonds of the food that we eat. But a match can also store chemical energy because it can burn. Now it's also thermal, but it's still chemical energy. And a battery, okay, is still chemical energy because there is a chemical reaction inside the battery that causes the electricity that eventually comes out of it. Nuclear energy, ladies and gentlemen, that is the splitting of atoms. That is the breaking apart of larger atoms into smaller ones, releasing their energy. That is what happens in a nuclear bomb. So you're talking about uranium, plutonium, carbon atoms. Atoms that can split apart and give off energy. Electrical energy, ladies and gentlemen, are batteries. Electrical outlets in the back of the room. Another type of battery is called a wet cell. That's the battery in your car. Why is it called a wet cell? Anybody know? Because, what?
Because it can't get wet.
Nope. Because there's a liquid inside it.
Oh.
There's a liquid inside it. Years ago, you used to have to take the top off of your battery and add water to them to keep them going. Nowadays, it's all sealed up. But inside the big battery in your car is sulfuric acid. That is the liquid in there. Now, the little 9-volt batteries, the AA, the battery in your cell phone, the battery that you're using to charge your computer right now possibly, those are called dry cells. They have a paste in them. They do not have water in them. Okay? Electromagnetic energy, ladies and gentlemen. Radio waves, light rays, and X-rays. This up here, ladies and gentlemen, this right here is the electromagnetic spectrum. These are different types of electromagnetic energy. Radio and TV waves. Cell phones operate on radio and TV waves. Microwaves, like you have in your home to heat your food. Infrared, like the remote controls that you have to control a VCR, a TV, things like that. Visible light, the light up above our heads. Ultraviolet light, the stuff that gives you a suntan in summer. X-rays, the stuff that can go through your skin and take a picture of your bone. And gamma rays, the stuff that they can use in chemotherapy, in radiation treatments to kill cancer cells. all forms of electromagnetic energy. Mechanical energy, ladies and gentlemen, is a falling object, an object on a shelf, or a stretched rubber band. Mechanical energy can be any of those things. These boxes up here have mechanical energy, okay? Because they're sitting up on a shelf, and they can fall. That is another kind, though. Yes, we're going to get into that right now, okay? So there is the object sitting up there which has potential, and there is an object that is moving which has kinetic. Kinetic means moving, ladies and gentlemen. Energy in an object that is moving. So any object that ever moves has kinetic energy. What is the only way you can't have kinetic energy? If you're not moving. So right now, does that desk have kinetic energy? You sure?
Yes.
Yes.
You're positive.
Because it can move.
But does it have kinetic energy right now?
No.
The only way it can have kinetic energy is if it's what?
Moving.
Isn't it moving?
No.
Really? We're not spinning around on the Earth's axis? We're not flying through space?
No.
We're not?
Yes, we are.
So the point is, it depends on how you look at it.
Yeah.
If you were to tell me this has no kinetic energy because it's not moving right now, I would agree with you. But if you want to get specific and say, Mr. Brand, on planet Earth, the Earth is always spinning. The Earth is always moving through space. Therefore, every object on Earth has kinetic energy. Okay, but you better explain it that way. Okay? Because I look at that and say it's not moving, it has no kinetic energy. Okay? Kinetic energy depends on two things. Two things determine the amount of kinetic energy an object has. What are they?
Velocity.
Mass and
Velocity.
velocity. What is velocity?
The object moving.
What?
The object moving.
What is velocity?
How fast an object is moving.
I don't want a formula. You're trying to do the right thing. All I want to know is, what does the term velocity mean?
How fast an object is moving.
How fast an object is moving. Thank you. Actually, velocity is how fast it's moving and what direction it's moving. Does direction matter? God darn right. Somebody points a gun at you, threatens to pull the trigger. Direction matters. The starter holds the gun up in the air and pulls the trigger. Direction, a lot safer, right?
Right.
Velocity means both, speed and direction. What does mass mean? Just simply, how what? How heavy it is, right? How heavy it is, ladies and gentlemen. Okay? So it depends on velocity, how fast the object is moving, and it depends on mass, how much matter is in the object. How much matter is in the object. Okay? There is a formula for this. I will not ask you questions that make you solve this formula. I just want to show it to you. Kinetic energy is 1/2 mv squared. What is m? What is v? Velocity. Okay? Kinetic energy is measured in something called joules. Anybody in here play baseball? Softball?
Used to.
Okay. This formula is kind of important to a baseball player. Why? Nope, not worried about how fast you pitch. Because when you pitch, you're pitching the ball, correct?
Mhm.
What can't change about the ball?
The direction.
Nope, direction can't change. Of these two things, what cannot change about the ball?
The mass.
The mass. You can't control that. I was thinking more the other end of that operation. Hitting the ball.
That's what I was thinking.
Choosing a bat.
Oh.
Do you want a heavier bat to create more kinetic energy? Or do you want a lighter bat that you can swing faster? That's where it really comes down to. Okay? Can you generate more kinetic energy with a lighter bat, or can you generate more with a heavier bat? Okay? Because the more kinetic energy you can generate, the further the ball is going to go when you hit it. Okay? M is for mass, measured in kilograms, kg. Velocity is V, meters per second, ladies and gentlemen. Again, these are units that we should be familiar with from either the last try or earlier in the year. Joules, kilograms, and meters per second. All right, ladies and gentlemen, so here's what we're going to do. You are going to get up in a minute and you are going to go to one of the tables in the back, ladies and gentlemen. We're going to do a little activity here to discover what factors affect kinetic energy. So we said there were two variables. There is the mass and there is the velocity. Well, a good experiment, how many variables do you change at a time? One. So the first time, ladies and gentlemen, this first experiment, we are going to try to make the speed constant. We are going to change the mass of the object, but try to make the speed constant. So what's going to happen is you're going to go back to the lab stations, ladies and gentlemen. You're going to partner up with somebody, and at the station, there are 3 different books, all of different masses. There is a notebook, which has a very light mass. There is the textbook for the class, which has a medium mass. And there is the CRC handbook, which has a large mass or a heavy mass. You are going to try to slide those across the table to your partner. You're going to try to slide them with the same amount of speed. So whether you are pushing or whether you are the one who is catching them on the other side of the table, and all you're doing is sliding them across, you are going to judge which one or what happens to the kinetic energy by how hard it is to either push it or how hard it is to stop it. Okay? So is the heavier object moving at the same speed as the lighter object harder or easier to stop? So you are going to record how difficult it is to push or to stop them. And you're going to simply use easy, hard, and medium. Okay? Easy, hard, or medium. So the first time you are going to do all 3 books, sliding them across the table. If there are 2 sets of people at a table, one can work with one book and then you can switch. Okay? The second time we're going to try to leave the mass constant, which means you're going to pick one of the 3 books. I don't care which, but only one of the 3 books. But now you're going to make the speed variable. So now you're going to push the book slowly to your partner, with a medium speed to your partner, and with a fast speed. And please do not try to kill your partner. Okay? Do not try to kill them. But again, you will judge which one of these was the hardest to stop or hardest to push. The one with the most velocity, the medium velocity, or the least. And then, ladies and gentlemen, when we increase the mass here, the kinetic energy, did it increase or decrease? And how do you know that? This is the summary for this part here. For this part here, it goes right here. When we increase the velocity, the kinetic energy, increase, decrease now. Okay? Faith, catch. Faith, catch. Why did you flinch the second time?
Because knowing you probably didn't think.
Okay. Well, knowing you probably wouldn't catch it. But anyway, ladies and gentlemen, more kinetic energy would mean that if the object comes and hits you, it's going to hit you with more or less force. Keep that in mind. Keep that in mind during this activity. The more force the object has, the reason it has more force is it has more kinetic energy. So when you're debating, was there a lot of kinetic energy or a little of kinetic energy, think, how hard was it to stop? How hard did I have to push to get it going? Okay? Everything is in the back, ladies and gentlemen. Let's go get it done. Come on. Partner up with somebody. Make sure your computers are off to the side so you don't slide it into your computers and send them flying. Mariana, it's a new class. You have a chance to work with somebody different, and you choose to go back and work with Faith.
Don't judge her. I'm awesome. Okay.
I'm not judging her. I'm criticizing her for making bad decisions.
You?
You can work at a table where there's already a group. Just borrow one of their books. Hardest thing is to try to get them to the same speed. Try to do your best. Okay, for the first set, you're trying to set all three at the same speed, but the difference is their mass. Okay? The difference is their mass. Again, try not to kill your partner. Make sure he's ready. Remember, you probably need to do all three together.
Is it this one?
You know what I mean? It's hard to do one and say, well, that was easy. When you have to Again, remember, this is difficult, but you're trying in the first part to set them at the same speed. So which one do you have to push harder to get it to go at the same speed as the other one? Which one is the easiest to push? Or if you're catching them, which one is the easiest to stop? Again, the one that's easiest to push should be the one that's easiest to stop. They go together, right?
The back has more friction.
No. All we're looking at is two things. We're looking at mass, and we're looking at speed, or velocity. Okay? No, I understand, but I want to keep it simple. What? Why? Are you trying to kill her?
I told her it was okay.
Come on, get your life out. You pick any one of them, and now you're going to try to set them at different speeds here. Slow, medium, and kind of fast. So now in the second one, our mass is staying the same, but we're changing our velocity. So again, which one is the easiest to stop? Which one is the easiest to make you go at that speed? In the boxes, you're putting like the easiest, the hardest, and the middle. So we're just like ranking 1, 2, 3. So which one was the hardest to stop? Which one was the easiest to stop? Which one was something in the middle? So you may want to do all three first. You may want to push it 3 times. Once fast, once medium, once slow, and get a feel for when it's harder to stop. The second time you're only doing one of the objects, ladies and gentlemen, just one of the objects. We're not studying the book thing. This is that's chemistry. We're not doing what? We're not getting into organic compounds. What? They're good for this, and they're good for reference. They're still accurate. They haven't changed the constants of chemistry over the years. Gold's density is still Gold's density. Gold's melting point is still Gold's melting point. Well, in here, you should rank it. Which one was the easiest? Which one was the hardest? Which one was the in between? So you should be able to say, okay, when we push them all at the same speed, which one of these was the easiest to stop? Which one of these was the hardest? Which one was somewhere in the middle? When we took one object and I sent it across slow versus medium versus fast, which one was the easiest to stop? Which one was the hardest to stop? So that's what you're doing in those boxes, is ranking.
Okay, so how hard is that? That's what I'm
First reading question.
Yeah, because it's
That's hard.
She has another computer. I was trying to see.
Broke down. So that a flight there on the side of the road? I would be too. Okay, let's get done, ladies and gentlemen. When you're done, you can head back to your seats. Slides should be completely filled out. If you have any questions, please let me know. I'll be happy to come over and give you some assistance.
So now you're picking one object. And no, you're picking one object. So if you do a little velocity, a medium velocity, or a whole lot of velocity, which one is easier to stop? So pick one object. Pick. Well, a little bit. Yeah. Which one is included? How difficult it was to stop. So was it really easy? Was it really hard? Yeah. So if she chucks it at you,
Like a maid.
is it going to be easy to stop it or hard to stop it?
It's not a contest to see who dies first over there.
I won.
You won because you died first, or you didn't die first?
Hold those.
We don't need the highlighters anymore, do we?
No. If you have any pens or pencils of mine or highlighters of mine, please put them back up on the front because you won't need them.
I'm feeling like very upset.
If you get here in time.
What?
She said if you get here on time.
What?
Part of the sentence do you not understand?
None of it.
By the way, ladies and gentlemen, somebody last try left me a jacket. I have no idea whose it is because it was just left at the end of the day. So
You said last try?
last try.
No, not us.
I understand. Some of you won't be there. All right, ladies and gentlemen. So real quickly here, let's summarize what we learned, hopefully. Okay. So if we held the mass constant, if the velocity went up, if the object was moving faster, does that mean more or less kinetic energy? What? More.
Yeah.
So, what do you notice about those two arrows, ladies and gentlemen?
One's going up and one's going down.
No.
Which one?
Right here. These two.
They're
Both going up. If we met with a lower velocity, what did that mean for the kinetic energy?
It's going down.
Okay. So, which type of relationship is it when both arrows are either going up or both arrows are going down?
It's direct.
That is a direct relationship. So if you just click on the box at the bottom, you can delete the one that we don't need, and you could take the arrows and move them here like I did. That is the relationship that we hopefully just learned, ladies and gentlemen. Okay? That if the velocity of an object increases, now again, the mass is not changing. Okay? If the velocity increases, its kinetic energy increases. If the velocity decreases, its kinetic energy decreases. So as you're going down the hill, the very first hill on a roller coaster, as you're going down and down and down, what is happening to your speed? What? It's getting faster, which means what's happening to your kinetic energy? It's increasing. But now you come to a hill and you start going up. What happens?
It decreases.
You start. Why?
Because of the friction.
What?
Because of the friction.
Okay, but why? Why does your kinetic energy decrease?
Because you need more.
Because you start slowing down. You start slowing down. When you're going downward on a roller coaster, you're going to go faster. When you go up, you're going to go. Even take a ball, throw it in the air. What happens is the ball goes higher and higher up.
Then it goes down.
No, what happens is the ball goes higher and higher up.
Go speed.
What?
Go speed.
Really? It goes faster?
No.
It slows down. Matter of fact, what does it do right before it starts coming back to the ground? It stops. All of its energy is gone. All of the kinetic. Why? Because if it stops, it has no kinetic. But then it starts falling again. And as the object is falling to the ground, what happens? Gains what? Why? Because it goes faster. Because it goes faster. Good, ladies and gentlemen. Questions? All right, that's all I got for you for today. Tomorrow we will look at potential energy, ladies and gentlemen. Tomorrow we'll look at potential.